so this is the second video on sequences, section 8.1 in BC Calc. We're going to start with reviewing some properties of limits and how they relate to limits of sequences. They really work about the same. You've got your sum and difference rules, where basically if you have a complicated sequence, you could think about it as two separate sequences, a sub n and b sub n, find their limits, and then add or subtract them accordingly. Same thing with the products. You could treat the functions separately, find their limits, then multiply the limits. Same thing if you have a constant times a sequence, and same thing if you have a quotient of sequences. You could find their limits and divide those. So those sort of tricks can help us sometimes if we're given a formula for a sequence and we're trying to determine whether or not the sequence would converge or diverge. So for example, here we have a sub n equals 3 plus negative 1 to the nth power. So I'm really going to split this up. I'm going to maybe think of it as b sub n equals 3. So there, it's done. That's its limit. And then c sub n is negative 1 to the nth power. So then I would focus on finding the limit as n approaches infinity of negative 1 to the nth power. So that could be a little tricky. But if we think about what that sequence actually is, well, negative 1 to the first would be negative 1, and then negative 1 to the second would be 1, negative 1 to the third would be negative 1, negative 1 to the fourth would be positive 1, and so on and so forth. This sequence is going to continue to oscillate back and forth between negative 1 and positive 1, so it's never actually going to converge to anything. So even though the b sub n part converges to 3, this guy diverges. If any portion of the sequence diverges, that makes the whole sequence diverge. All right, then we have b down here. We have b sub n equals n over 1 minus 2n. Now, you could split this up and do the limit for n and the limit for 1 minus 2n, but I honestly think I would keep it like it is and do n behavior model for it. I also am going to start by writing some terms out just to see if they kind of start to maybe level off in any way. So if we substitute a 1 in, we get negative 1, and then with 2 we get negative 2/3, and with 3 we get negative 3/5. So it looks like they're not doing anything wild and crazy, so this guy most likely will converge. But the question is, what does he converge to? So again, since it's a limit to infinity, we can do n behavior model. So this would be the limit as n goes to infinity of n over negative 2n, which is negative 1/2. So b sub n converges to negative 1/2, which means that if I kept writing out terms for b sub n, they would start to get closer and closer to a value of negative 1/2. So that's the beginnings of how we're going to determine convergence for sequences. The next thing that we're going to look at is called the sandwich theorem. So the sandwich theorem, it's basically you're making a sandwich. You're trying to determine values that the sequence has to stay between, and they basically form the two pieces of bread. And then the sequence itself is your meat inside the sandwich. So you're kind of smushing your sequence in between those two limit values. And if those two limit values approach the same thing, then that means that your sequence converges to that as well. So here we have, for example, cosine of n over n. And we want to show that it converges, so that means it does. We just have to show why it does. And then we have to find the value of its limit. Well, here's what I know about cosine of n. If I look at the cosine graph, or if I think about my values of cosine around the unit circle, they are all between negative 1 and positive 1. Like there's no cosine value that goes outside of that realm. So negative 1 and positive 1 basically are the bread of my sandwich, and the cosine of n is the meat of the sandwich. So that also then tells me if I was to look at the absolute value of this sequence, this would be like the absolute value of cosine of n over the absolute value of n. Well, if cosine is between negative 1 and positive 1, then the absolute value could be is a value of 1 over the absolute value of n. So regardless of whether n is positive or negative, that's always going to work out to be less than or equal to 1 over n. Here's why. Because if n, well, n's got to be a positive number because it's your term number, so it's always got to be positive. So, yeah, I should probably write these like this because it's a sandwich. So less than or equal to. So 1 over n is essentially the same as cosine n over n as we continue to write more and more terms out. So the limit as n approaches infinity for 1 over n is 0. So then by the sandwich theorem, the limit as n approaches infinity for cosine of n over n is also 0. So cosine of n over n converges to 0. I personally do not like the sandwich theorem. I'm not a fan of it. I feel like it's just kind of the trick you pull out when you have no other means available to show why something converges. Like I try every other method I know of before I try to use the sandwich theorem. Now, the sandwich theorem can also be used to prove the absolute value theorem. So what the absolute value theorem says is that if you have a sequence a sub n, if the limit of the absolute value of that sequence is 0, then that means that the limit of the original sequence without the absolute value on it is also 0. So for example, I have c sub n equals -1 to the nth power times 1 over n factorial. And I want to show that it converges and find what it converges to. So with that, if I write out some terms there, -1 to the 1 would be -1 over 1 factorial is just 1, so I would have a -1. -1 to the 2 would become a positive 1 over 2 factorial, so that would be 2 over 2, which is 1. -1 to the third would be -1 over 3 factorial. 3 factorial is 3 times 2 times 1, so that would be -1/6. And then -1 to the fourth would be 1 over 4 factorial, which is 4 times 3 times 2, so that would be 1 over 24. It looks like it's oscillating, but the values are also decreasing as it's oscillating. So you actually have, like if this was my x-axis, I have a negative number, positive number, a smaller negative number, smaller positive number, then another smaller negative, smaller positive, smaller negative, smaller. So do you notice what's happening to those values? They are starting to converge. They're just converging from two sides. So they're converging to 0. But let's see how I can use the absolute value function or theorem to show that. If I was to take the absolute value of this expression, really all that does to this expression is get rid of the -1. So this is just 1 over n factorial then, because the negative would never happen if it was an absolute value function. So the limit as n goes to infinity for the absolute value of c sub n would be 1 over infinity factorial, which is 1 over infinity, which would be 0. Therefore, the limit as n approaches infinity for c sub n is also 0, and that sequence converges to 0. So that wraps up our introduction to sequences. I hope it has not been too painful for you.